All right, video 3, because I know you can't hear enough of me as a disembodied head. So let's hook you up with integrals. You learned about antiderivatives. For example, you learned that if I have, if I want to take the, if f of x equals 3x squared, then f prime of x, the first derivative, then f of x is going to be 3x cubed over 3, because this is going to go up a power. And that number's going to go on the bottom. We get x cubed, which is good. There is one thing that I wish that the other video had covered. I guess I could do it over again, but I am lazy. So is if you have to take two derivatives, like let's say that you have this is f of x is x cubed, f prime of x is 3x squared, f double prime of x would be the next derivative. That would be 6x. In the Leibniz notation, this is just going to be f of x. This is this is df dx, and this is d squared f over dx squared. Again, it's just telling you that it's a second derivative of the function with respect to x. That's all the terminology means. An integral is really just an antiderivative. That's all it really is. We're going to talk about why it's actually important. Okay, if we have a, if we say it's really just an antiderivative with some special stuff attached. So, for example, if first you've probably seen the little scrolly thing. Okay. If and it has the integrand or whatever it is, whatever the symbol is called, I can never remember. It has some function, let's say 3x squared, and it's dx. So this is going to tell me what I'm operating with respect to. This is a little symbol. It tells me I'm doing it. So this is called an indefinite integral. Doesn't give us any numbers to plug in. All it really does is the way to solve it, you're just gonna take the antiderivative respect to, I think that's the integrand, this piece up here. If not, yell at me in class, because I really would like to fix it. So for this one, the integral of 3x squared dx is going to be the integral of that, which is x cubed over 3 times 3. Okay. So that's the same as before, but we're going to add a constant. I'll explain why. And this just becomes, sorry, that goes away. Okay. X cubed over 3, no, sorry, just x cubed plus c. The reason that we have this constant here is because let's say that originally it had a number. let's say that we had x cubed plus 7 as our function. Well, the first integral of it would be 3x squared. But if I had f of x equaled x cubed plus 347, this would still be 3x squared because the root of that is 0. So it's going to be some constant when you walk back on it. Usually, to get rid of that problem, they'll tell you what the value is. They'll tell you the value of the function when x or the variable is 0, or well, that's usually what they do. You don't have to worry about that if you have a definite integral, though. Yeah, so this part kind of went off the screen here. It's 347. Sorry. Okay. But if you have for a definite integral, you don't have that problem because it has limits. It is an integral with limits. So let's say we go back to the one we had. We have 3x squared dx, but now we're going to have some numbers on the side. Let's say from 1 to 8. These are the limits. This is the lower limit. That's the upper limit. And all those mean are that when you're done taking your integral, you just plug those limits in. So what you'll do is, we already know the integral of this, but we're going to say that it's from, so it's going to be, we know the integral, or the inner derivative, I'm sorry, is x cubed, right? But now, in order to get that, that's what we got before. But we're going to actually evaluate it from, it's going to be 8 cubed minus 1 cubed. Sometimes you'll also see this written with a little line that indicates the limits, 1 and 8. So it's 8 times 8 is 64. 64 times 8 is 512. So it'd be 512 minus 1, 511. Let's say we have a more complex one. Like the ever famous what should we do? Oh, let's do a 3t squared plus 2t plus 8 from 0 to 5. Make that dt. I want to point out this dx, then I'm just adding an x to every one of these terms, but we'll try that in a second. So this one here would be 3t cubed over 3 plus 2t squared over 2 plus 8t evaluated from 0 to 5. So for the first one, it would be 5 cubed plus, those divide out nicely, plus 5 squared plus 8 times 5, which is 40, minus 0 cubed plus 0 squared plus 8 times 0. Again, I don't expect you to write this. I'm just doing it for instructional purposes. So it's 125 plus 25 plus 40. We get 190 for the answer there. I did want to point out that example that I started to talk about illicitly. If I have 3t squared plus 5t plus 7 dx, well, none of these have any x's, so the actual answer would be 3t squared x plus 5xt plus 7x. Again, assuming that x does not depend on t. If it does, then you got other problems, which you could probably solve in Calc 3, maybe come up with some parametric things. There's lots of fun things you can do. That should be enough. And I'm out.